Hello, everyone. Hello, and welcome to the next episode of She Builds Tech Skills Europe, Middle East, and Africa. My name is Julia Bluszcz, and I'm a data scientist from ProServe team based in Warsaw, in Poland. And I'm super excited to welcome all of you, to our July episode. I hope that you're all familiar with our show format so far, because not to brag, but this is already our fifth episode. But to all the folks who are joining us for the first time, a quick reminder what we are all about. So, She Builds Tech Skills is a show dedicated to really help underrepresented communities in tech to get access to hands-on trainings and to share knowledge between fellow tech enthusiasts. And we really want to create this supportive and inclusive environment, basically for technical training. And as always, I'm joined by my amazing co-host, Antonia. Antonia, how are you doing today?
Doing great. Heat wave is slowly passing over Europe, so it's getting more comfortable. So thanks for the intro. I'm Antonia. I'm also a data scientist from AWS based in Berlin. And today we have two exciting new people on board. So I'm very happy to introduce Velisva as another co-host to our Tech Skills show. And it's very important that we have Velisva on board because she's based in Africa. So finally, we're getting out of Europe and we're getting some African representation here. So Velisva, you want to intro yourself?
Thank you, Antonia. Thank you, Julia. Hi, everybody. I'm Veliswa Boya. I'm a developer advocate here at AWS. So I am based in Africa. I'm in South Africa. I'm super excited to be here on this show.
Awesome.
Yeah, we are too.
Exactly. Finally, a developer advocate again. After Chris left, this is a nice replacement. Thanks a lot. And also, we have Sara joining us today. So Sara is our guest speaker. She's a senior solutions architect at AWS based in Netherlands. And I'm going to borrow the teaser from Velisva. She builds and she also breaks things on purpose. And that's what she's going to talk us through today. So she's going to talk about chaos engineering, resilience, scalability, everything you need to know around that topic. So Sara, over to you. Tell us a bit about yourself.
Hi, everyone. Can you hear me?
Yes.
All right. So first of all, I'm very honored and happy to be here. Thank you so much for having me. And so as you mentioned, I am a solutions architect working with AWS customers. Mainly think about scale ups, companies that are cloud native. And I work with customers based in the Benelux. That means customers based in the Netherlands, based in Belgium and Luxembourg. And as part of my role, I help customers being successful in architecting cost-efficient, reliable, and scalable cloud architectures in the AWS cloud. Yeah.
Sounds amazing.
So that's a bit about me.
Maybe before we jump to the technical part of our today's meeting, a bit of a disclaimer. So there wouldn't be the topic of chaos engineering without a bit of chaos during our today's stream. So we are experiencing a little bit of technical troubles with the connection. So if one of us will be a bit dropping on and off from the stream, please bear with us. This is the beauty of real-time streaming. So please be patient. Yes.
Yes, everything fails all the time, right? So we're gonna have to take into account also live streaming and network connections. So first of all, so the topic of today is going to be chaos engineering, and I'm going to introduce you a bit over the topic and why is that important for you and your team and your company. And I will also show you a very small demo on how can you actually practices within your team and on your application, if you like. So first of all, let me start by the concept of. I want to start by the Well Architected framework, which is a set of resources and they provide guidance for AWS customers to architecting the AWS cloud. We have a number of pillars. One of them being the reliability, and one of the goals of reliability is to design and have a fault tolerant application in your production environment. This is important not only for your business, because this mitigates disruption from the customer side, so they have a graceful experience, but also it's also, in my opinion, important for the health of your team, the health of your engineering team, to make sure that you know exactly how your system behavior plays out, and you want to rely on automation to make sure that your system behaves to injection to failures in a way that is the best way for your customers. So that being said, so we provide a set of guidance when it comes to guidelines when it comes to reliability. So there is a self-service tool, which is the well-architected tool, which you can use in the AWS console. We also have another way to improve the reliability of your services, of your application, is chaos engineering. And some of you might be already familiar with the concept of chaos engineering. Some of you might not. It was made popular by Netflix mainly. It's one of the companies that evangelized the practice as well. So
Yeah,
what is
I
chaos
think that
engineering?
everybody heard about this chaos monkey, right? Like this was the most famous application of chaos engineering, at least from my experience.
Nice. Yeah, that's correct. And so I'm assuming, I'm not giving for granted that everybody in this live streaming will know what is chaos engineering. So in short, chaos engineering is a process that essentially stress your application in either a test, staging, or production environment. And the way it works is that you create disruptive events, so events that create chaos by definition. And after these events that you create and inject yourself in a control environment, you observe how your system responds. And based on your observation, you take out learnings, and you see what is your system behavior, what are some opportunities to improve your system based on your observation, and then you implement those improvements based on your findings. And some of the benefits for both you as a developer, your team, and your organization there are many benefits. Some of them being like uncover issues that are difficult to find, exposed what are those monitoring or observability or blind spots that you have, failure modes that you didn't think about. Like actually, I think one of my favorite benefits is like really try to think more in depth about what are the failure modes of the production services that I use, and thinking about it this way allows you to, first of all, know better what services you have in production and how do they behave, and also that increase the confidence over the services. On top of that, you can find performance bottlenecks, and also another benefits, if you have an on-call, if you own a product, a service that is that needs an on-call rota. For instance, running those experiments during working hours in a control environment is way better for you as opposed to waking up at 4 a.m. By this pager notification alarm. So I think it's a better experience overall that is a win-win for many stakeholders involved in this process.
Then I have one question here. So how can you actually define all these unexpected things that could happen? So they are unexpected by definition. So is there like a predefined list of things you can check for, or?
So that depends. So the failure modes of your system really are defined by what components is your system composed of. So first of all, I think that if we think about this process, like let's say you want to get started, but you don't know where to get started. First of all, the first thing that you would like to do in this process is identify what is going to be the target application, as I mentioned, because the failure modes are also bound to that kind of application that you have. So if this is your first experiment and you don't know where to start, I think I would start first of all with a pre-production environment. So mitigate, reduce those risks as much as possible, or a test environment. And then as your practices becomes more mature, then you can introduce different folds or more like more complexity in your experiments. And then you can continuously assess that resilience also then in your production environment. So based on this, then you may want to know what is the definition of a steady state behavior. So how and what are the metrics that will tell me, okay, this is my steady state, this is my customers, my own consumers are having having a positive experience. So I would start with what are the metrics, what are the technical metrics and business metrics that tell me, okay, the system is behaving as I want. So for instance, if you have an EC2 instance, that could be latency or CPU load. If your system is based on serverless, so you have maybe an API gateway or a Lambda function, you have different metrics. So for if you have, in general, you have business metrics. So for instance, the number of failed logins per minute, or the number of retries, the speed of page load. So these dimensions are really tied to your system. You know your system very well, and it's also tied to what your business goals are, so what is critical for your business when it comes to this application. But yeah, these are the next step. And finally, once you have these two initial phases defined, the next step is form an hypothesis. What do you expect from these experiments? An example, like normally this hypothesis is something like, if this happens, this business or technical metric impact should not exceed this threshold. So you define the threshold based on your system, based on your components, based on how much your system is on the critical path, and so on. And one example could be, for instance, if the network latency increased by 10%, then there would be less than 1% increase in login failures. And then after you do the experiment, you evaluate if the application resilience is in line with your expectations, both from a business perspective and also on a technical perspective. Yeah, hope this answers the question a bit.
Sure. Thanks so much. I think that we can slowly get to the hands-on part. So
Okay.
you mentioned that you prepared a demo for us today.
Yes, I did.
What are we going to break?
So let me first share my screen.
During this demo, I'll do a brief introduction to chaos engineering in practice on a AWS environment using the AWS Fault Injection Simulator service, which is a fully managed chaos engineering service. The workload that I will target is running on EC2. It's managed by an auto-scaling group that runs with a minimum of 2 EC2 instances and a maximum of 3 EC2 instances in total across multiple availability zones. On the EC2 instances themselves, we are running Nginx and PHP. In the screen now, you can see the high-level architecture diagram of how the workload looks like. So in the AWS console, we can, let me refresh. We can confirm that right now the target group of our workload has two EC2 instances running. They are both healthy, they are on two different availability zones, no unhealthy instances, nothing weird that I'm looking at. Notice also the name of both instances, which is fault injection simulator stack autoscaling group / autoscaling group. We will use later this name to target those instances for our experiment. So for the scope of this very introductory demo, we can assess the state of our workload in different ways. So first of all, we can do that by actually accessing the web application running on those EC2 instances that are exposed by the load balancer. In our case, we are actually accessing the welcome page of Nginx, nothing fancy. Alternatively, we can also access the PHP info page as well behind the same load balancer here, as you can see. We also have a monitoring dashboard. This will allow us to gain insights from a more observability perspective. In this dashboard, we have a number of widgets that tell us a bit more about the experience of our consumers, based, for instance, here, based on the HTTP status that our service is returning to the consumers. So in this case, we see that it's right now it's entirely 200 type of status codes. That's good. 500 means error, so that's not something we want to see. We have also some information about latency from a consumer perspective. We have some information about the connection status of our Nginx server, the response time. Right now, it's pretty good. We have some information about the server CPU. We can see now that it's mostly idle, so that's also okay for now. And we also see that, as we confirm in the other in the web console, in the target group page, right now we are running two EC2 instances, and the maximum size of the autoscaling group is 3. So that being said, let's start with the fault injection simulator service. So let's start with the experiments. The service itself allows you to create templates for your experiments. You can create templates using the AWS console, using the CLI, or even infrastructure as code by using CloudFormation. This is nice because you can store them in version control. So let me start an experiment right away. Actually, first, let me show you what kind of experiment am I going to run? So I want to observe the following. So given the architecture that I just showed to you, the workload that I want to target, my hypothesis is that the failure of a single EC2 instance may lead to slower response time, but should not affect the service availability for our consumers or our customers. So I already create one template for this demo, which is in the screen. And what this template is going to do, what fault injection simulator is going to do, is going to terminate 50% of the instances based on the name tag that I've given. And the name tag that I've given is the name tag that I showed you a few minutes ago. So let me start the experiment. Okay, let's start. Okay, so now that we started our experiment, let me dive deeper into what you're actually seeing here. in this page. So how does an experiment look like in practice? So first of all, in this tab, you can, let me refresh. Okay, so this is already completed. So we have fault injection actions. An action is an activity that the service performs on one or more AWS resources during an experiment. The service gives, the fault injection simulator service gives a set of pre-configured actions based on the type of AWS resource that you want to target. It can be a target, it can be a host, it can be an infrastructure, it can be network. Specifically in terms of AWS services that you can target, we have, sorry, we have IAM, we have EC2, we have ECS, EKS, and RDS. You can integrate actions with CloudWatch Alarms or System Manager. Next to that, we have targets. As I mentioned, targets are resources that are selected for the specific fault injection experiment. You can select targets based on tags. It could be based on instance ID or cluster ID and so on. We also have a timeline, and for your experiment, you can set a duration for each action. In this case, the first action will lasts a minute, and it will essentially terminate those instances. And the second action is gonna essentially wait a bit, and the whole experiment lasts 3 minutes in total, as we can see. So let's have a look at the auto-scaling group to see what happened. So let me refresh. So as you can see, the fault injection simulator actually terminated an instance that was taken out of the service. And we also, as a response from our auto-scaling group, is that we are launching now a new instance, because this is the behavior of the auto-scaling group. We should have always a minimum of 2 EC2 instances. So the moment that the fault injection simulator dropped the instance, terminated the instance, it started a new one. So we can see this also in the autoscaler. Let me look at the this is also confirmed from the EC2 instance. So we used to have 2 healthy instances. Now we have only 1 healthy and 1 that is spinning up. So that's as a consequence of the fault injection simulator service. Let's have a look at the behavior of the application from a user perspective. I am doing some refresh, and I can observe nothing specific, no error whatsoever. So let's go to the dashboard. The dashboard here tells me, in fact, confirms that right now we have 1 EC2 instance in service, while the minimum capacity is still 2. Let me see what else we can observe. So this is in the last minutes. So let's have a look at the behavior of the service in the last minute. So we can observe that there has been most of our responses that we return to the consumers were indeed successful, but there were unsuccessful responses too. So I do see some responses with the 500 status code returned, which is of course not ideal, not what we wanted. We see as well a spike when it comes to the latency. It used to be pretty steady. Now we can observe a spike, but in terms of the maximum duration and the average duration of the latency in terms of response time. We don't observe anything specific. There you go. Actually, we do observe a spike in the server's response time. So indeed, the increased latency in response time, both from our consumer perspective, but also from the server perspective, within the server. This is actually something that we expected. What we didn't expect and that we didn't want is the fact that we return some errors to our consumers. So this is the something that we can observe through our experiment. And we our hypothesis indeed, what I want to go back to what our hypothesis said. Our hypothesis said that the failure of a single EC2 instance may lead to slower response time, which is confirmed, but should not affect the service availability of our consumer. This was not confirmed because the availability was affected. We did return some errors to our consumers. And what are some learnings that we can take out of this? So first of all, this workload as two EC2 instances as a minimum. Sorry, as a minimum. And spinning up a new EC2 instances takes time. As we saw from the console, there was the initialization of a new EC2 instance took some time when I was looking at the target group, and that has an impact on the availability of the overall application. So in this case, two EC2 instances were not enough to maintain the level of availability that we wanted. So having multiple EC2 instances or multiple availability zones is something that would be better. So redundancy of computing units in this case, more than what we have. So this is all when it comes to our demo. Hope this was useful. And again, it was very introductory. But yeah, hope you got a small bite of what the fault injection simulator can do. Thank you.